Dear friends, today I am going to explain Ohm's law, the statement and the derivation in relation with the expression of the drift velocity and how it is that. So let me start. Let I take a conductor. So this is my conductor, cylindrical in shape, having length L and area of cross section like A. What is the volume of this conductor? It is L into A. Now I explain number density, number of electrons per unit volume in this conductor. Let it is N. N is number of electrons per unit volume. I mean to say, if the volume is 1 unit, then electrons number is N. If the volume is L into A, then electron number will be N, L, A. Now then, what is the charge, total charge, free charge? I mean, they are free electrons. They are moving in random directions. And I am interested finding the charge in this cylindrical conductor. Number of electrons equals to NLA here. And the charge on one electron is minus E. And total charge will be, it is E, N, L, A. Of course with negative sign because they are the electrons, but let I consider the magnitude of the charge, it is Q, N, E, A, L. Now, you know very well, the electrons, if you apply some potential here, you apply some potential like positive, negative, positive, negative. What happened? Before applying this potential V, the electron was moving in random direction. Some were moving along this side, some were along this side, some were moving up, some were down. But applying the potential, the electron starts drifting. Drifting means you go along this side like this. This is called drifting. The path is not exactly a straight path. It is zigzag path. But finally the target is they are reaching towards the positive potential. Here it is positive potential. This is positive potential. So they are reaching towards the positive potential. Why zigzag path? Because of there are thermal velocities. So electron having the thermal velocity also, that's why it cannot move exactly a straight line. It cannot follow a straight line. So right. Now let the time taken by the electron to move from this end to this end is t. And the charge is q. Okay. Now then what would be the current? Because that electron is now drifting. If it is electron is drifting, it is moving in a specific direction. Now there will be current. So current is equals to charge over time. What is small t? Time taken from here to here. Substituting Q, which is E N L A divided by T. Okay, so this is our current. This is our current. Now, electron is drifting with velocity Vd, and electron move from here to here, and drift velocity is very 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 small, approximately 10 to the power 4 meter per second, approximately. I mean to say it is very small. And drift velocity means this distance, which is L, divided by the time taken by the electron moving from this end to this end. So drift velocity is distance over time. And T becomes from here, T is equals to L upon Vd. Okay. Now substituting this T here, then current becomes E N L E divided by L and Vd. Okay, then this L and this L cancels. Over the current becomes equals to what? This is NEAVD, this expression, NEAVD. So this is the current flowing in this cylindrical conductor. Now you know the expression of the drift velocity. The expression of drift velocity is E charge of the electron, electric field which is applied, relaxation time over M. If you don't know this expression, please go to my video. I'm giving this link in the description box. Okay? And where I explained how this equation is. Right. Otherwise you can understand, there's no problem here. Because E into E, what it is? Electrical, this is actually a force. Because electrical field is force upon charge. So this is actually a force. And if this is force, F equals to ma. So this is ma tau upon m. So mm cancels. So acceleration into the time. What is this tau? Tau is time between the two successive collisions. Because electron, when it moves from here to this point, there is a possibility that it makes a collision here. Then again it makes a collision here. So the time, for this collision, the time is different. But we take the average time between the two successive collisions. And this time is called relaxation time. So it is A into tau, acceleration into time. This is velocity. So no problem. So it's very easy to understand. Okay, drift velocity is E tau by m. Now I'm substituting drift velocity in this expression. So current becomes N E A Vd mean E tau upon m. Now the equation becomes I is equals to N E and E square E tau upon m. Okay, this is the expression of the current. Now electric field, which is which is applied, we applied a potential here, which is V, distance is L. Now, what is the electric field? By definition, electric field is potential divided by the distance. So, electric field is potential over distance. Substituting this E here, then current becomes equals to N E square E tau V by L, and it is M also. So this is the expression of the current. Okay. Now from here, voltage over current becomes, taking this I to this side and whole parameters to this side. So V over I becomes equals to M L over N E square E tau. Okay. Now, for a given conductor, M is mass of the electron, it is constant. For a given conductor, L is constant. For a given conductor and a given material, N is constant and depend upon the type of material. It is copper or silver, like that. Electronic charge, this is constant. Area, this is a geometry factor. It depend upon the geometry. But if your conductor is for a non-conductor, for a given conductor, A is also constant. Tau, relaxation time. Relaxation time means time between two collisions. This time depends upon the temperature. If the temperature is high, then electron will collide more frequently. Then there will be more collisions. If the temperature is high, then there will be more collisions, and collision times decreases for high temperature. If temperature is low, then there will be a few number of collisions, less number of collisions, and then time between the two collisions, it increases. So for low temperature, tau is greater. For high temperature, tau is less. But if the temperature is constant, then tau becomes constant. That means this whole factor, it is constant. So this V upon I, this whole factor depends upon given material, given geometry and temperature. If they are constants, then V upon I becomes constant. Let we call it R. R is constant, and it is called, this constant is called R, and I is taken to this side. So R into I. This constant is called electrical resistance of the conductor. Okay, electrical resistance of the conductor. Now what is the reason of the resistance? Resistance means the opposition. Opposition means like this is the electron. Electron to go here, positive potential, but it makes the collisions. Okay, it gone colliding. So it is finding difficulty for reaching here. If it finds less difficulty, the R will be less. If it finds more difficulty reaching here, R will be more. If the temperature is high, more collisions, less relaxation time. Less relaxation time means it is in the denominator. Time is less means this factor will be more, means R will be high. When R is high, when temperature is high. If the temperature is low, then less collisions, more time between the two collisions, more time in tau increases, the whole factor decreases, mean R decreases. So electrical resistance then it is less. So R depends upon the temperature also. Of course, R also depends upon the geometry, like length and area of cross section. Okay, it also depends upon length and area of cross section. And moreover, R also depend upon N, number density. Number density depend upon the materials. So this is all about what is R. Now here we learn that R is equals to ml upon n e square a into tau. Geometric factors L and E. That means R is proportional to L. Mean if the length is small, there are two lengths. One is small, one is large. Electron find less difficulty reaching here to here and find more difficulty reaching here to here because path length is more. So it is proportional to L. It is inversely proportional to area of cross section. Okay, if you are having two materials, same length, but different area of cross section, what do you think? Electron find less difficulty for reaching here to here because area of cross section is more. Here it finds more difficulty reaching here to here because this is very thin. Okay, less difficulty here, more difficulty here. So area is less, R will be more. Combining the two, so R proportional to L upon A. Replacing proportional sign by a constant, so R is equals to rho L upon A. Now, before going to discuss what this constant, of course, this constant is called electrical resistivity of the material. And this rho is equals to R A upon L. Okay, if I substituting the value of this R here, and what the resistivity becomes then? Resistivity becomes ml n e square a tau. This is R. Then this A divided by L. Which L? This one. A cancels, L cancels. So what is the expression of the resistivity? The expression of resistivity is it is m upon n e square tau. Now what is the difference between resistivity and the resistance? This was the resistance. And what is the difference? Here there is L and E. Here there is no L and E. Mean resistance depends upon the geometry, but resistivity is independent of the geometry. There is no L, there is no E. Rest of the parameters they are the same. Resistivity also depends upon the temperature as R depends upon the temperature. But resistivity is independent of the length and area of cross section, but R depends. Okay, So it is, it is helpful, it is good to talk about resistivity instead of resistance, because here you have to mention what is the length of the conductor, what is area. But if you talk about resistivity, then no need of saying about length and area. It is independent. So resistivity only depends upon the material, mean number density and temperature. Now coming to the units lastly, you know, the Ohm's law is V equals to IR. Ohm's law is V equals to R into I, and R equals to V upon I. So if V it is in volt and this current it is in ampere, then R will be in. Now lastly about the Ohm's law, V equals to Ri and R equals to V upon I. So this resistance it is measured in ohm, when potential it is in volt, and current when it is in ampere. So 1 ohm is 1 volt per ampere. I mean to say, if you are having a conductor and if you have applied 1 volt potential difference, if that potential difference makes a current here 1 ampere, then the resistance of this conductor is said to be 1 ohm. If 1 volts makes 1 ampere current, then the resistance is said to be 1 ohm. Now one thing is again very, very important, because V equals to Ri. If you draw a graph between volt and current, the graph is exactly a straight line. If you draw a graph between V and I, then it will be a straight line. Now what is the slope of this line? This angle is theta. What is tan theta? Tan theta is perpendicular divided by the base. Okay, what is perpendicular? You know, this current and this current, I2, I1, and here to here is I2 minus I1, mean delta I. This voltage V1, this voltage V1, this voltage V2. What is voltage here to here? V2 minus V1. This is delta V. So tan theta is perpendicular delta I upon base delta V. So what is current over voltage? You know, voltage over current is resistance. But current over voltage is the reverse of resistance, 1 upon R. Resistance means the opposition. But if you take the inverse of R, it becomes conductance. The reverse of resistance is conductance. Here the slope will give you the value of conductance. If you are having the two lines, V and I, this is one line, this is another line. If I say which is having more conductance, then your answer will be the 2 is having more conductance, because the slope is high, here the slope is less. If I say which is having more resistance, Okay, you will say because the line 1 is having less conductance means more resistance. Here more conductance means less resistance. And it becomes other way if I plot a graph between I and V. So this is 1, this is 2. Now here the slope directly gives you the, because this is V and I. Okay, graph is V is here, I is here. So tan theta equals to V upon I. V upon I is resistance. This is the resistance. So this slope directly gives you the resistance. So if along this side it is I, if along this side it is voltage, then slope is conductance. If this side it is current, then slope is resistance. That line 2 is having more resistance. Line 1 is having less resistance. That means 2 more resistance, less conductance. Here less resistance, but more conductance. So keep in mind. And resistivity L upon A. Resistivity equals to R, A upon L. That it is ohm. Area of cross section it is in meter square upon meter. So this is ohm meter. The unit of resistivity is ohm meter. And the reverse of resistivity is conductivity. That is ohm inverse and meter inverse. So conductivity is not symbol C, it is symbol sigma. Sigma is conductivity per ohm per meter. Rho is resistivity ohm meter. Okay. So this is all about the Ohm's law, and any circuit which obeys a straight line, graph between V and I straight line, that circuit is called the linear circuit. The Ohm's law is obeyed and it is a linear circuit if the graph between V and I is a straight line, because then R having only one value. R is having only single value. Single value means linear circuit. Okay, thank you.